Good morning, everyone. Thank you for joining us for the Mukuyu-2 preliminary results sidetrack and forward plan update. I'm just going to give it 1 or 2 more minutes to let everyone who's waiting to come in arrive, and then we'll get underway. Okay. Good morning, everyone. Thank you for joining me. My name is Scott Macmillan. I'm the Managing Director and CEO of Invictus Energy. This morning, we're going to run through the Mukuyu-2 preliminary results, the sidetrack and the forward plan. Please forgive me if I'm a little blurry-eyed. It's 2 a.m. here in Zimbabwe, and it's been a challenging few weeks, but exciting. So this morning, we put out an ASX announcement regarding the preliminary results for Mukuyu-2. A lot to unpack in this announcement. There's quite a lot of details, so I'm not going to read through this word by word. Instead, I'm going to summarize a couple of the major sections of this announcement, go through that in some detail to provide some context, and then give an update of what the forward plan is going to be. So, firstly, we recovered some hydrocarbons to surface. Fantastic results for the company, for this basin, and that was achieved from the Pebliarcos, an interval that we were primarily targeting for a water sample above the upper and lower Angua to provide a calibration of the resistivity of the water leg, which allows us to calculate the gas saturation in the upper and the lower Angua and the other reservoirs. So this gas was recovered after we took a water sample. Here's the sample chamber of the tool, which was recovered to surface, and in that was some natural gas from a depth of 2,197.3 meters. So prior to going in to do the sampling, the fluid sampling, we interpreted the logs in the Pebliarcos as water bearing with residual gas. So what that means is that the gas saturation was below the net pay cutoff that we use, and so we thought that this was going to be predominantly water, but we were pleasantly surprised when we recovered some gas when we were blowing down the sample. So this interval we were able to sample because it's above the zone where we had some differential sticking in the well. So we've had some challenging borehole conditions that have been brought about by having to raise the mud weight in the lower part of this well as we got through the bottom 300 meters or so in the lower Angua towards total depth, and this has caused some losses and invasion in all parts of the reservoir that we've seen. And when we pumped out the water, we pumped out over 200 liters and to try and achieve cleanup for this water sample, to watching the resistivity real time. So there's a lot of invasion in this. We'll go through the drilling and the mud weight increase in a second. This gas composition is natural gas, predominantly methane, with some trace heavy ends as well. So completely validated our log interpretation. And proves the presence of hydrocarbons and the migration of it through the structure. So we've seen residual gas all through the upper parts of the Triassic and into the Jurassic and Cretaceous in the Dandy. This is the first time that we've been able to bring a sample to surface, though, and not just from log interpretation. So obviously a huge result in that sense. Even though it's residual gas, but in this location, and it was always always likely to be the case because it's in an upthrown horse block, there's some lateral fault seal or lack of it on the sides, and I'll show you that right at the end. So we're not in a 4-way dip closure in this little horse block, so it's there's top seal, but there's no lateral seal on the sides. But in other places in Mukuyu, where we've got favorable trapping geometries, and this applies to the Danny Formation as well, this is obviously a huge result and will result in the trapping of hydrocarbons in places in the structure where it's conducive and has those lateral seal qualities. So very, very good results in the Pebbly Arcos. And then moving on to the upper and the lower angler results to date. With the same logs that we've interpreted, we've got multiple hydrocarbon bearing reservoirs in both the upper and the lower angler. We TD'd the well at 3,718 meters while still in gas shows. We did begin to encounter some overpressure from 3,400 meters on to TD. So going into this drilling program, we took the data from Mukuyu-1. We had an idea of the formation pressures and the pore pressure regime that we were going to be drilling through the shallow reservoirs in the upper Angler, Pebbly Arcos, Forest and the Dandy. And in the first part of the low Angler that we penetrated, it was normally pressured. However, when we began to get into the deeper gas legs, we encountered overpressure. And again, this is I think, we executed very, very well for the first 3,400 meters of this well, and everything went according to plan, according to our modeling, and until we got into this overpressure zone in the lower Angler. So first time it's been penetrated, and it's an unknown pore pressure regime. What that required us to do, though, is raise the mud weight to ensure that we maintain control of the well and ensure the safety of the operations, and that's what we have to ensure first and foremost. However, since that occurred, it has caused challenges and complications for us in the subsequent part of the evaluation of the well and the wireline. So we first saw that with the connection gases when we were drilling, and then with the high amounts of trip gas that we saw that were seeping into the wellbore when it was stationary and we came back in. So formation pressures, when we've subsequently got pressures from the boreholes exceeding 5,000 psi in the lower Angler, probably down to 5,500 psi right at the bottom of the well. So very, very high pressured, and that of course brings its own challenges. Good for for pressurization and flow rates and everything else, but it does bring drilling challenges if you're not prepared for it. And the mud weight that we had in the shallow parts of the well was too low. So we needed to increase the mud weight to maintain control, and that has complicated logging operations. So we've had differential sticking of the wireline cable. We prefer to gather our log data from wireline because it's a much nimbler and a much easier process to do, running in and out on cable rather than drill pipe. So the first couple of runs we managed to do with wireline, but as soon as we got to the parts of the program, particularly sampling, which require you to be stationary on the borehole wall for long periods of time, we began to see the cable sticking to the side of the borehole. So this example here of some fluid cleanup that was going on to acquire a sample in the lower Angler. This was at a depth of, sorry, I beg your pardon, in the upper Angler, 2,900 and I can't read that small. The small numbers on my screen, forgive me. So this cleanup, I'll just run through this here. We've got time on the bottom. We have got two fluid analyzers here, one looking at the gas stream and one looking at the liquid hydrocarbon stream. So this dark color here is basically mud filtrate, or drilling mud rather, and then this is the filtrate. Once we stop, we place the probe on the borehole wall, and then we've started sucking fluid from inside the reservoir. This is the filtrate, which when you drill, you put a filter cake on the inside of the borehole, and then the water-based mud penetrates into the reservoir. So we're starting to move that through the fluid analyzer that's close to the in the near wellbore, and then we've got some gas that's beginning to come through once that started to be cleaned away, and then we've got some liquid hydrocarbons which appear. So on this station, we began to clean up. We saw hydrocarbons through the tool, but we began to see some differential sticking of the wireline cable, which meant that we were likely to get stuck if we stayed there. And so we we came off station, but when we did, we saw a huge amount of overpull, over 17,000 pounds of overpull, which is right at the very limit of the cable's capability. So once that happened, and we brought the tools back to surface, we then observed that we damaged some of the primary sampling tool, Saturn, and then elected to go in on pipe and bed logging from there. So whilst we were waiting for some replacement parts, we went in with the backup tools and went in on pipe. And because of the borehole conditions, with the instability of it caused by a lot of washouts, we had to do multiple wiper trips to clean up the hole to allow the tools to pass through it. And we've got some ledges and washouts in some of the coley sections of the borehole. When we were running in, when your tools are on drill pipe, they're quite rigid. And so if they're on wire, they can kind of find the middle of the hole and go down gently. But when it's on pipe, you're pushing it into the hole. And if you've got sharp edges on the borehole caused by washouts, you can damage the tool. So this is what's happened. And after a couple of issues where we damaged the tools again with the secondary logging tools, we've had to, and further restrictions in the borehole, we've made the decision now that we need to sidetrack this well and drill the upper and the lower angua, or the top part of the lower angua that we penetrated down to 3,400 meters, with a sidetrack that will be planned for the drilling conditions that we've encountered, and allow us to then go and complete our fluid sampling and the rest of our data gathering that we require. So that includes sidewall cores, VSP, and obviously some fluid samples. So it's exciting results today, but it has been challenging, and that has really been as a result of the borehole conditions and the mud weight that we needed to employ to maintain control of the well and make sure that we didn't have a blowout. So the all-in shot of this, though, is we have satisfied the criteria from a Society of Petroleum Engineers petroleum resource management system, which is what we operate under on the ASX, that we've met a discovery criteria. However, the company has elected to continue with the program and go and acquire a fluid sample and fulfill our objectives of the well. And we want to fulfill the standards that we set for ourselves in doing that. So although it is disappointing that we have to sidetrack this well, I think nonetheless we're still very excited by what we've seen, and it's a pretty historic result so far, and something that's very pleasing to have been validated. It would have been fantastic to get this all done in one go. It is still only the second well in the basin, and it's the first time we've drilled into the lower angua. So we are going to get some surprises when we do these operations, both good and bad. But I think we've done phenomenally well for what is still a very, very frontier region, and some excitement ahead of us. So unlike the Mukuyu-1 sidetrack, which we conducted previously, this is going to be a very simple vertical sidetrack. So this is roughly where the casing shoe is here. This yellow horizon is the top of the upper angua. This green horizon is in the pebbly arcos. So that sample was gathered from somewhere roughly here. So we will come out of the 9 5/8 shoe and just drop vertically and just drill vertically down to 3,400 meters. Much easier to execute and much simpler. So we have learned a huge amount from this well and from the drilling operations and how we need to plan and execute our wells, our well design, as well in future wells in Mukuyu and in the basin as well. So I think in future we're going to push our casing down to the top of the upper angua, which will provide us with a better mud weight window down through the upper and the lower angua, and allow us to optimize that mud weight further. A few changes to the mud chemistry as well, which we've learned as well from this Mukuyu-2 section. And that will allow us to drill this relatively efficiently. So having considered all of the options and how to continue to fulfill our objectives, we ended up in conjunction with our service providers concluding that sidetracking the 8.5-inch hole was the optimal way to go. That's for a couple of reasons. I think really 8.5-inch hole, it's always better to drill in bigger size hole than 6-inch. It will allow us to execute a relatively simple vertical sidetrack, and it will also allow us to then run the 7-inch liner in this hole section, preserve that, and then we've still got the ability to drill out in 6-inch hole and test the remaining parts of the lower angler as well, both from a wireline perspective and then also in a future flow test as well. So that gives us the maximum flexibility and also the greatest chances of success with the hole size and the tools that we have available. So so that decision was made on Friday afternoon, Zimbabwe time, and since then we've begun the preparation and currently plugging back the borehole in Mukuyu-2, getting ready for drilling out probably sometime later this week, where we'll then begin the sidetrack kickoff and then drill vertically from there. So we're anticipating that total operation, so that's to complete the drilling, the logging, and running the and suspending the well roughly 21 to 28 days, depending on operations and how they go. The company is funded to complete the sidetrack and that activity. Again, part of the reason that we went out for that capital raise prior to the start of drilling was for scenarios exactly like this, and we've had this contingency funding in place to fulfill this, and we're able to continue on, and the company's in a good position to do that immediately and not have to stop and try and find a solution to continue from a financial perspective. So we're in a good space from that perspective, and it was the right decision. So once this is done, we'll suspend Mukuyu-2 for a future test. We've been planning some of those activities in the background and looking to do that and tag on some drilling as well next year. So that will allow for the suspension of this 8.5-inch hole section, and then we can come back and whilst we are planning the test for these sections of the upper and lower angler, we can get everything we need ready and drill out the 6-inch hole, log and evaluate that, test it, the bottom parts of the lower angler, and then test in the 7-inch liner here. We'll probably do this in open hole on the 6-inch. So that's where we've ended up, and so we've got a busy period ahead of us, and I must give credit to all of our team, our contractors. It has been challenging. Everyone's been working collaboratively and together to come up with a solution. We've had a fantastic result now with hydrocarbons recovered surface. We've fulfilled the discovery criteria from a listing rules and an industry perspective. So that's obviously a phenomenal and a huge and a monumental result for the company and our shareholders as well. And very grateful to all of our shareholders for your support and your patience. It has been very trying, and no one feels this more than we do to deliver for our shareholders. And we've got a little bit ahead of us, but we've got a good plan now that we're going to be able to execute on, and be able to provide results in the next 3 to 4 weeks once it's all done. So just a reminder of what we came in to do was to prove up the discovery in Mukuyu-2. We've done that from a definition criteria, but as I said, we want to fulfill the objectives of what we came to do, which is to get fluid samples from both the upper and the lower angler, and bring that to surface. We've got, as I mentioned, the Pebliarcos will represent a really interesting target in other parts of the world. It is in this upthrown horse block through here. and we don't have lateral seal across these faults where the hydrocarbons are able to leak out. We have seen also residual hydrocarbons all the way through in the well and into the Dandy, as we put out in our previous release. And again, we've got this lateral fault seal issue across here in the Dandy, but in other parts of the structure, these are still going to come into their own. So again, second well in the basin, we're still learning lots. There's still a lot of secrets that need to be given up by this basin and by this field. But we've got now a few weeks of operations ahead of us before we deliver final results. So I've got time for one or two questions. Unfortunately, I've got other calls that I've scheduled that I'll be hosting. So I'll just allow a couple here that have raised their hands. James?
Yes, sorry. Congratulations, Scott, on your progress so far. Just a quick question on LWD. Is that a possibility? And also, what about potentially incrementally wirelining the sidetrack? So I know I'm not a reservoir engineer or drilling engineer, but is there anything to be said for drilling the sidetrack in sections and wirelining in stages?
Look, it's a good question. We will have LWD. We've got a limited suite of LWD because it doesn't provide you the resolution of data that you need for what we're doing at this stage. So because it's only the second one in the basin, we need to get really detailed information, which comes from the wireline, because your resolution is 2 inches versus LWD, which averages it over kind of 2 or 3 meters sometimes, depending on the tool that you're talking about. So wireline is our primary data source. We use LWD to guide our drilling operations rather than evaluating. So we get some information from that, but it's not the ultimate evaluator. It's also, as I said, very coarse data, but also sometimes intermittent depending on the drilling conditions as well, because it is affected by vibration and pump rates and a lot of other things. The second part of your question on incremental wireline, what happens with drilling and wireline is if you do it in stages, you've got to pull your drill string out, rig up your wireline, run in, do all of those suites, which take our wireline program is pretty extensive because we're in an appraisal phase and data gathering. So that takes anywhere up to a week to complete all of those runs of wireline. So to drill it out, and we're expecting to take roughly a week to 10 days to complete the drilling of this section. To break that up in stages as we go through would add incremental time and incremental risk onto the program. So it's better to just do it in one hit. We've now got a good handle on where the overpressure kicks in, and we've got the mud weight window to keep it to keep it appropriate down to that 3,400 meter mark. So we've got a plan, and we'll be able to do it much more efficiently. So that's why we do it in those stages. However, we are going to change up the order of our data acquisition for the wireline to make sure that we go and prioritize the fluid sampling first and foremost. So that order of the runs that of when we do our primary log, which are gamma ray, density, neutron, and resistivity, and then we'll go in straight after that because we've got our iron now in this well. So we've got a fair idea of where we need to go based on the primary log data, what we're looking for. But we are getting a big data suite in as well.
Thank you.
I've probably got time for one more question. Lawrence. Sorry, Lawrence, I think you're muted there.
Can you hear me now?
Yes.
Oh, right. Sorry, Scott. Thanks very much for making the time available for us this morning. Just in terms of setting casing, so we acquire the samples hopefully from both the upper and the lower angua, run the appropriate logs, etc. After doing that, maybe acquiring some cores as well, sidewall cores. Could you just repeat what you said about setting casing? Is that just to the upper part of the upper angua, and when you terminate from there, you have to just stop or fill in cement for the
there might be a bit of confusion there. So our casing shoe is currently over here, the 9 5/8" casing shoe with that with this white dotted line kicks off. So we're going to set a series of plugs through all above the hydrocarbon zones to isolate them so that the well's left in a safe state, the original well bore, and then we'll drop down out of the shoe. At the shoe, it's roughly a 9-degree inclination, so we'll just simply drop vertically, and a plug will be set near that shoe, and we've got the acoustic properties of the sand, so we'll pick a location where it's soft, where we've set the top of that plug. When your drill bit goes in to start the sidetrack, it'll hit the cement, and you do what's called time drilling, and it will preferentially drill in towards the softer part of the sediment. And once you've kicked off and you start to see your returns of what you're drilling out not being cement and being formation, you then stop, pull that sidetrack bottom hole assembly off. So you come back to surface, and then you put on your LWD suites and all of your production hole drilling bottom hole assembly that you use then to drill out and evaluate this hole whilst you're drilling. So the sidetrack is a couple of steps in terms of the operational sequence before you actually start drilling again. But what I was getting at with the casing shoe was, in future we will push all of these casing strings a bit deeper, which will allow us to drill deeper in each of these hole sections, and allow us to have a better window for mud weight. At the moment, the mud weight heaviness is limited by the pressure in the pebiarcos, which is obviously the lower pressure out of all of these. So once you start getting into the lower angua here, where the pressure ramps up, and you've got to increase the mud weight, you're starting to get above the sort of fracture gradients in the pebiarcos. And if it's too heavy, you start to take losses to the formation, and then you start to lose control of the well. So you've got to put in a lot of circulation material to heal up all of your losses. So it's a cascading effect if you don't get the mud weight right. So look, it's as I said, second well in the basin. We're still learning a lot from it. This formation's never been drilled before in the lower angua, but we've got a better handle of it, and we've got some pressure data out of it as well, so we can calibrate our drilling program for the sidetrack, but also for future wells in the basin.
So the final completion testing casing will go a portion of the upper angua, but not the full section of the upper angua. Is that
the full section of the upper angua and partially into the lower angua? We'll then preserve. We'll run the liner or whatever the drilling engineers decide to do to preserve this 8.5-inch hole. Then when we come back to do the test of this, we will drill out the 6-inch hole, because we'll have some liner in here, and then we'll be able to drill with a reset mud weight that's more appropriate for this formation. And drilling 6-inch hole, we'll be able to get deeper than where we are now, 3,750 as well. So there are a number of benefits to that. I'm afraid I've got another call at 2:30. I know there's lots of questions, and please feel free to follow up if you've got any questions. Again, thank you for your support to all of our shareholders. Very, very exciting for the company and the future of this basin. And again, thanks to all of our team for all of their hard work over the last few weeks, and look forward to delivering results, complete results, I should say, in the next few weeks. So thank you and take care.